Okay, now for today's work, I have a new worksheet, but it's the same problem, which I thought was kind of funny and coincidental. So, given this unbalanced equation, which I've just rebalanced for us, basically we have a bunch of these same kinds of conversions. We're going from moles of this to moles of that, moles of this to moles of that. This is arguably maybe a little bit easier than the one that we did before. You guys will be responsible for doing these ones. So these are grams to moles. But again, it's stuff that we were doing last lesson, so should be not too difficult. I'll get you guys set up with that in just a second. So let's take a look here. So given the unbalanced equation, right, if 4.5 moles of this are used, how many moles of oxygen are required? So we know that over here, right, our answer is going to be in blank moles of oxygen, okay? And we know that we're given 4.50 moles of C2H6. Okay, and so what we need to do is we need to convert from this, right, to this one. Okay, so it's 2 to 5 is the ratio. So since we're converting from moles to moles, we don't have to go through grams, which is like super, super nice. So in order to get, let's give ourselves a little bit more space here, because this is only a one-step problem. So what we're going to do is we have moles C2H6, right? So we want C2H6 to be in the bottom here, right? Conversion factors. Okay, moles C2H6. There are 2, according to our equation, 2 moles of C2H6 per every 5 moles of oxygen. Okay, and so what that's going to mean is we're just going to plug this into our calculator because, right, like I said in the previous video, this matches this, so we're done, right? All we have to do is calculate. So it's 4.5 times 5 divided by 2. That's going to give us 11.25 moles. See? Super easy. Let's see. Actually, I was going to do this whole section, and I'm just going to let you guys do this section. Let's actually skip down here, right? And we will do the first one here, and you guys will be doing this one, and this one, and this one. You guys will do these 3, and I will do this one here. So, given the unbalanced equation below, right, how many grams of H2SO4 are needed to react with 0.75 moles of NaOH? So, first thing we got to do here is balance this equation. If you take a look at this, we know that SO4 is a polyatomic ion. If you didn't know that, you can still balance it. But basically, counting the H's over here and the H's over here and the NA's, right? I know that I'm going to need a 2 here to balance these sodiums out. And then this 2 is going to cause me to put a 2 over here. And then once you kind of take a look at everything, it is balanced. So how many grams of H2SO4 are needed to react with this many moles of NaOH? So again, this is what we're starting with. So we're going to write that down first. 0.75 moles of NaOH. And then our answer is going to be in grams of H2SO4. Grams up here. Grams H2SO4. Okay, so we're in moles, we want grams, we're using this thing. First, we're going to convert into moles of H2SO4, because we already have the moles, right? So remember, this is calculating in moles. So we have this, sorry, where am I at? We have this, right? We need this, okay? It's a 2-to-1 ratio. So 2 moles of NaOH, 1 mole of H2SO4. Now we're not done yet, right? Because this is moles of H2SO4. This is grams of H2SO4. So we need one more conversion factor to convert it to grams, and then we're done. Then it's over. So 1 mole, right? Again, canceling our units, 1 mole of H2SO4. I really need to figure out these brushes, make this a nicer looking experience. So when you look at p-table, again, I'm going to try to simplify this. When you look at p-table, the number of grams of H2SO4 is going to be, if we're busy rounding up to the nearest whole number, it should be about 98. About 98 grams. Okay, so then we're done, right? And if you don't believe me, right, we can cancel these out. Nice blue color. Do I have blue? Blue. So, right, moles of NaOH, moles of NaOH, moles of H2SO4, moles of H2SO4, and it's in the units that we want. So all we have to literally do is math. Just plug this in. 0.75 divided by 2, that number, times 98 is going to give us 36.75 grams H2SO4. Okay? So I'm going to try to upload these written in ones with the examples so that you guys can actually like use this and write in it. And you can see my examples as you're going. You don't have to like go back into the video and whatever. So yeah, you guys will be responsible for those 3 problems. Again, they're just very straightforward, right? Just convert one thing to another. This one appears moles to moles. Make sure that you guys are paying attention to that. So it's just a straight mole to mole conversion, right? This is one step. And then down here, these will be 2-step because you're converting from grams to moles. Okay? So I hope that you guys have a wonderful Wednesday, and I will see you in the next one. Bye-bye.